Today's lesson is on the triangle midsegment theorem. Our vocabulary for today is midsegment of a triangle. A midsegment of a triangle is a segment that joins the midpoints of two sides of the triangle. Make sure you don't confuse midsegments and medians. Medians connect the vertex to a midpoint. Midsegment connects two different midpoints. Every triangle has three midsegments, which form the midsegment triangle, which is shown with x, y, z. So the midsegments are x, y, y, z, and x, z, x. And the midsegment triangle is triangle XYZ. For this example, we have the vertices of a triangle at -1, 8, 9, 2, and 3, -4. And M and N are the midpoints of XZ and YZ. We want to show that MN is parallel to XY, and MN is half of XY. First, we find the coordinates of M and N. So the midpoint of XZ, we use the midpoint formula, which I've written to the right, that -1 plus 3 over 2 is 1, and 8 plus -4 over 2 is 2. The midpoint of YZ is 9 plus 3 over 2, and 2 plus -4 over 2, which comes out to 6, -1. So the midpoint of XZ, remember, it said the midpoint of XZ was M, so M is 1, 2. Make sure you write that down. And YZ, the midpoint was N, so N is 6, -1. So those are the 2 points we need to know. Now we need to compare the slopes. So the slope of MN is -3/5 by using the slope formula, change in y over change in x. The slope of XY is -3/5 as well. So they are parallel to each other because they have the same slopes. Remember, perpendicular is negative reciprocal, parallel, same slope. The second thing we had to show was that the heights were one half of the other. So what we're going to do first is find the distance of MN by doing the distance formula. 6 minus 1 squared plus -1 minus 2 squared equals square root of 34. Here I wrote the steps underneath to help out a little bit. This is 5 squared plus -3 squared, or 25 plus 9, and that's where we get the square root of 34. The second one for XY is 9 minus -1, which is 10 squared, plus 2 minus 8, which is -6 squared, which gives us 100, plus 36, which is 136. And if you need to simplify that by taking out a 4 to give you the square root of 4, remember, is 2. That gives us 2 radical 34. And I wrote the distance formula there on the left for you in case you don't remember it. Since the square root of 34 is equal to 1/2 of 2 times the square root of 34, MN is equal to 1/2 of XY. Make sure you know this proof because this is one of the proofs that's in your Common Core standards. So if you know this proof, it's very possible that it's going to come up on your end of year examination. In the relationship shown in example 1 is true for 3 midsegments of every triangle. So the theorem, the triangle midsegment theorem, says that DE is parallel to AC and DE is equal to 1/2 of AC. So the midsegment is parallel to the base and it's equal to 1/2 of the base. So this is our proof using the triangle midsegment theorem. We're going to go ahead and find BD. So BD is 1/2 of the base, which is AE. AE is 17, so BD is 1/2 of 17, which is 8.5. Not too hard of a problem. We're taking the base, dividing it in half. That's the midsegment. Here we want to find the measure of JL, and we know the midsegment. PN is the midsegment. So if PN is the midsegment, and it is equal to 36, we multiply both sides by 2, and 2 times 36 is 72. So JL is 72 because it is twice the midsegment. If we're trying to find PM, PM is the midsegment of the base LK. So it's half LK. Substitute 97 for LK. PM is half of LK, so it's going to be equal to 48.5. Let's look at an angle. If we want to find the measure of MLK, we know that the two lines are parallel. MP is parallel to LK, and these are corresponding angles. If we have corresponding angles, they're congruent, and so MLK is also 102 degrees. So if JMP is 102, the one below it is also 102. And I went ahead and marked the congruent angles so that you can see them there. Here's your lesson quiz. Take some time to practice, see if you have any questions, and make sure that you know that theorem, the midsegment theorem, and how to prove it, because like I said, that's very likely to come up on your exam. And if you have any questions on any of this, please feel free to ask questions during class tomorrow.